Hello everyone, welcome back to Path for Cloud. So in today's video, we will continue to our storage discussion, which we started in last video, where we have seen like how you can create a static storage, right? So in terms of Kubernetes, we have discussed we have two types of storage. One is static and another one is dynamic. So in static, we have seen that you need to create a PV, then you need to create a PVC, and then you need to assign to that particular pod. That's how that static work, right? So we have seen okay, these were the definition file which we tested in our last video, like pod with the host path, how you can define a local directory and then you can assign to a pod, right? So that we have seen here. So in today's video, we will see what is dynamic storage, right? So as the name suggests, dynamic, right? Like which is something dynamic in nature. Like you don't need to worry about the storage, whether you need to provision it or you need to, let's say, what you call that, the size you need to define. No, dynamic is something whenever a pod is required, right? Pod request a storage, right? This dynamic storage will get auto provisioned. Storage gets provisioned, and maybe the size earlier, let's say it has requested 100 GB, right? Or 10 GB, let's say, right? And somehow it is full, right? And now you don't need to worry about that extension of that particular storage share, right? It will automatically get provisioned whatever that threshold you define, right? So in this way, what will happen? Now you will say that how auto provision will happen with the pod, right? So in order to get this done, right, what is the thing is we need to provision some provisioner, right? So provisioner is required here, and there are lot of provisioner which Kubernetes supports. Like we have uh, Azure disk, we have AWS disk. In Azure disk, again Azure NFS or maybe a block data storage you are talking about, that also you can attach, right? I will take you to that documentation where we can refer all these, right? But let's see first how a dynamic storage work and what is the provisioner, right? So provisioner, as I mentioned, provisioner is something a kind of it's a CSI, right? Like container storage interface, which is already built up by many of the vendor, right? You just need to install it, right? You just in Kubernetes we don't install generally. Like we what we do is we run that particular YAML file and it will create a pod for that thing, right? And there it will gonna provision that thing. Now this provision will take care whenever you create a storage class, right? Yeah, there is a new term in this because here we don't need to deal with PVC, right? We are not dealing with the PVC because PV is a kind of static, right? Which we need to create. Being an admin, you need to create a PV and then you can claim that PV using a PVC, which is a persistent volume claim, right? Here, what you need to do is you just need to define your provisioner and you need to just define your storage class. What we put in storage class you will put, let's say I have given to name as a SC1, right? Whenever I am defining my PVC, right? So in SC1, whenever you are doing, right, you need to define that, okay, which provisioner it will gonna use to define that storage class. So storage class is nothing. Storage class is something which will help you to provision, right? Like whenever you want a PVC or maybe the disk from the external storage, right? So you don't need to every time you need to create the disk or then you need to claim. No, storage class will help you and it will automatically get that disk created on that external disk, right? And how? That's where this provisioner helps us. All right. So now you just need to create a storage class which will notify the provisioner, and whatever the provisioner, there are multiple parameters like if it is something that auto extension feature is there for that particular provision, you can mention that flag and it will automatically get extended, right? You need to define that what kind of storage, let's say in terms of Azure I am talking about. So in Azure, what you need to do is you need to define a disk type in terms of performance, right? Whether you need a HDD, SSD, premium disk, that thing also you can define, right? So that is how this provisioner work, which will be called by your storage class. And then once that storage class is there, right, you just need to create the PVC, right? Here the PV still in picture, right? It will be there, but you don't need to create this PV. What will happen is when you call the PVC, right, using the storage class ask provisioner to spin up a disk, and that disk will be created as a PV physical volume, sorry, persistent volume there, and then that volume will be claimed. So this part is auto provisioned using the storage class and provisioner, right? You just need to create a PVC, and then again the same process, that PV you can consume in your pod, right? So this is how this dynamic process works. Okay, so let's see in action. So what I have done is I have tried to do this Azure disk, right? But it was not fulfilling because I am using a local VM, right? It is something required to be run on where it is required to be run on Azure itself, right? So anyways, so I have found something called rancher.io local path, right? It is a kind of local provisioner which will create a local path on your host, and then it will be consumed as a storage class, right? So what I have done is I have created this file, right? But to do this, what you need to do is you need to first create this local provisioner, right? You can directly run this if path is not reaching or something. So what I have done is I have downloaded this YAML file in one time local path provisioner YAML. We can run this file and we can get our provisioner done. Okay, so let's quickly run it. It is done. So let me just increase little bit font so that it will be easy for us. Okay, 12 is good. Yeah, now it looks good. So what it has done is it has created a dedicated namespace called local path storage. Then it have created a service account. Don't worry, we will need to discuss this user management part like RBAC, how it works, and the service account, right? So that will be in our queue already. And it has defined some role for that. These are just role binding, and then it has created a this storage class and the config map just to use. So config map and deployment we have already done. So let me see, it is a local path storage, right? So let's clear a screen, and what I will do is get all -n. I am just specifying the namespace. So here you can see it has created a pod called this, which is running since 58 seconds. It has this deployment and the replica set, right? So this is how it is done. Now, if I gonna create my storage class, kubectl get sc. Sc is just to short form for your storage class, right? Okay, there is something which we can see. Let me kubectl API resources. I think this is the command. Yes. So here you can see we have these API which is supported in this environment, right? We have this binding is the name. If any short name is specific to that particular name, that you can use. Like I'm using the SC, right? So SC is somewhere. Yeah, here you can see storage classes, right? So SC, that's what that it has reverted me the storage classes, right? This is the API version, and whether it's a namespace or it is not name, because there are few object which is not bind to that particular namespace, right? There may be a kind of different namespace. You can see here storage class is not a namespace resource, right? It can be called in a different namespace as well, right? And what is the kind? That storage class. If you see our file, so that's what I have put. Not this one, we need to check 31. So this is the API version, right? Storage class. You can see storage k8.io v1, right? And kind is storage class. And that's just the name of our storage class. This is the provisioner I am using, and this is the volume binding mode. So volume binding mode, let me specify what exactly this is. There are two type of volume binding. One is the wait for consumer, and another one is something called immediate. So what does that mean is, wait for first consumer is like when you created your storage class, right? And if you created a PVC also from that, right? PVC will not get binded until unless you will not request it. Right, that's what. But whenever you created a new pod using that storage class and PVC, right, then only that PVC will get binded. And there is one is something called immediate, right? That depends on your infra, like how you want to use and what all the use case you have. But generally, immediate will be sorry, wait for first consumer is the recommended one for your what you say that cloud. Let me clarify why. Let's say you have running a high availability cluster with 10 nodes, right? Your node 1 to 5 is running, let's say, on availability zone 1, okay, and your node 6 to 10, I'm just giving some random example, okay, in availability zone 2, right? Now you have created a storage class, right, using a Azure disk provisioner, right? Whenever you are creating a storage class, and if you put a immediate, right, so what it will do is it will gonna create that disk in maybe in Azure, AZ zone 2 or AZ zone 1, right, availability zone from the cloud perspective. And whenever you are scheduling your pod, right, might be that, let's say, with this immediate effect, your disk get created in Azure zone 2, right, availability zone 2. And when you scheduled your pod, right, Kubernetes cluster scheduler has scheduled your pod in AZ1. Now, there might be a possibility whether your schedule will get failed if you don't have the sufficient right to read that particular disk from that different zone, or if you have that zone, everything is good enough, you will might face a performance issue, right? So that is why wait for first consumer is recommended whenever you the Kubernetes will going to schedule your pod, right? Let's say it is scheduling your pod in Azure AZ1. At the same time, the disk will get provisioned in the same zone, right? So we'll not face all these issues. That's how that the use case of this what do you say that wait for consumer. That is the workflow, right? When you say PVC, right? It will be in kind of pending mode, not binding. When you create a pod, right? Then only this PVC will get created and it will be binded to your particular pod. That's how we have done here, right? In this file, let me clear again, and if I just run kubectl get sc, so this is the local path sc we have created. Again, reclaim policy, which we have already discussed, right? Reclaim policy is something that the delete, right? Delete is something when you gonna delete your PVC, automatically that will got deleted. It is recommended for a kind of a development environment where you want to keep, you don't don't take care of your data, right? You are not to worry. But in kind of production environment where you are worried about your data, then the recommendation for the reclaim policy is retain, because when you delete your PVC, right, disk will not get deleted, disk will be there. If disk is there, obviously the data will be there. You can go and you can access the data anytime. So this is something use case for production environment, or maybe in databases or stateful app, right, where you need kind of manual intervention to check the data or something. That's what this thing is. All right. So we have created our local provisioner, and we have created our this something storage class. Okay. Now if you see this 32, what I am doing is I am directly creating a PVC. I'm not creating a PV, right? This PVC I am creating, this PV will get auto generated using this storage class. So here you can see what I'm doing is I'm just putting a persistent volume claim. I'm just giving some path, so name to that my PVC. This is the access write mode. Resources I am doing this. Earlier, if you remember, right? If I just cat this 29, so here we are not PV. I think it is under PV. Under PV, you can see that we were defining a host path, like we were mentioning, okay, from where you need to create a disk, right? Or PV or all these things. So here you can see I'm not specifying anything. I'm just requesting a 1 GB of space from the storage class called local path SC, which we just created using this. Okay. So now, what is the name of file? 32, right? I am gonna now if I just say get PV and PVC, you can see that PV is still not created. Why? Because it is in pending state and it is pending due to the volume binding mode. Wait for first consumer. The moment you schedule your pod, right, it will be scheduling your PV as well, and your PVC will get in binded mode status. Okay, so this is the file. Let me show you what we are doing here. I'm just defining the same image example I'm taking here, which we took for the static storage. Same, it is gonna just print some date in every 5 seconds and will get binded into this one. Volume bound, this path will be the same, irrespective of you are using a static or a dynamic, because you are telling to the container from the spec section what is the volume mount. I am using a local storage and I am mounting it to under data. But from where this storage comes from? This comes from this persistent volume claim, and the claim name is again the same local SCPVC, which we just created here. All right. So let's quickly schedule. Now it has scheduled, and if I get my PVC, okay, it is still pending. That should not be the case. Local SCPVC, that's what we have done. Okay, yeah, it just took time, right? Anyways, now you can see this is the PVC is automatically created. I haven't created anything here, right? It just took 30 seconds or so. So that's why I got confused. But yeah, we have the PV and PVC in place, and earlier the status was pending. Now, if you see, we have the PV, and when the PV was created, when we scheduled our pod, the PV get created and the status changed for the PVC to the bound. It is bounded to that particular PVC. PV, not PVC. Don't confuse with this name, right? It is a persistent volume. You can check the property name here. It is a persistent volume claim and it is a persistent volume. So you can see it has automatically created. Now, if I want to see, right, kubectl get pods hyphen o wide. So it has scheduled on node 1. Now, if I just want to know, right, where my this system is generating that data, if I just say kubectl describe PVC and this one. So it is bounded for this storage class. I just want to know that the path of that storage class. Okay, it is not showing. Then maybe we just need to describe SC. And what is the SC we have done? We have created a SC called this one, local path SC. So it is this one. Again, it is not showing. So let's give a try to PV. And our PV name is this one. Okay, there was a typo. Okay, so here you can see the path. Right? Let me clarify what I have wanted to achieve is, see, I can see my pod is scheduled on my Kubernetes node 1, right? And there obviously it is gonna schedule that or put all the data. I just want to see this data whether it is coming or not. Obviously you can go inside that pod with the execute command and you can run this, right? That we can do anytime. But I just want to know this path is automatically get created using the storage class, right? We haven't created. If I go to my node 1 and if I just go opt local path, and if I see, so here you can see you have that PVC. If you go inside, then you have this test log. And if I just say give me the live entry, you can see it is giving me this. So let it be now. You can see next 5 seconds. So data is being getting written here. So that's what we have good. But here, since the case is we are using a storage class, which is again kind of local provisioner, right? Rancher.io is a local provisioner. If you see this file, again, it is a local path. It is not, I'm not using external storage because I don't have the resources to use, right? I'm running this cluster on my local system. And here you can see it is giving me that path where I have this data getting right. Now, if I just want to delete my pod, delete pod, and the pod name was local sc pod, pod is deleted. It will take a little bit time, and then the storage gets free, right? Because we are not using that storage much. So let it be, and then I will show you. Okay, so it is deleted now, and data is no more coming. You can see 1722. We have 1, 2, 3, 4, 5. Because no application is running, so obviously there is no data being written. And data is still there. Why? Because if I now check my PV and PVC, okay, you don't need to give space here. It is still binded. That doesn't mean you deleted your port, then with the reclaim policy, delete is something that your data get deleted. No, it is still binded. Why? Because you have deleted your, you have already ran a pod using this PV and PVC. But if I gonna delete my PVC, delete PVC, and if I just specify my PVC name, it is deleted. Now you can see you don't have any PV, and PV get automatically deleted. And what about the data? Probably you just need to go one step back, and here you can see we don't have that PVC which was there earlier. Whereas if you have changed this policy delete to maybe retain or something, then your data disk will be there. You don't need to worry about the data. Data will be there. Now data is gone. So that is the reason that whenever, whatever the use case you are using, you need to make sure what type of policy you are using, whether it's a delete or it's a retain. Same way for the what do you call that, this access volume binding mode, wait for first consumer or it's say immediate, right? That depends on the use case purely. But if specifically if you are using somewhere in the cloud, then it is recommended to to make this compliance, which we took example here for this pod. All right, let me clear my screen, and again I need to clear. What I want to show you is there is something called no. Although here what I am doing is I am using a storage class, right? But I am using a no provisioner because I don't have any provisioner, right? So here little bit catch here. Whenever you have that auto provisioner is there, you don't need to worry about the PV. But whenever you are using a storage class, it's just a kind of example I am taking as the no provisioner. Where what I need to do is I just need to manually create the PV, otherwise your schedule will get failed. The same thing. It is the same thing for the storage class. If I just show you that provisioner one, here I'm using a provisioner as called rancher.io local path. Here I'm using a kubernetes.io no provisioner. Same volume binding mode. Here also volume binding mode. And the metadata, that's just the name of that particular storage class. Let me quickly create this and then I will show you the next step. Okay, it is 34. We have created a different pod anyways. Now, if I just run kubectl get sc, so we have one more storage class created called local storage static sc. Now, what next? I just need to define my PV as I mentioned, right? Because here there is no provisioner which can help you to provision your disk. So you need to specify your PV your manually. So same thing, I'm just specifying the 1 GB access mode is this one, storage is this one, local path is this one. But here is a catch. Make sure this exists on your VM. MNT disk vol 1. Let me show you. As of now, nothing is there. So let's see what will happen if we directly run this. So here there is two more thing. I have just taken a two example here just for more clarity here. One is the node affinity and one is the node selector. If you remember that in terms of scheduler we have discussed these two terms. Node affinity is something where you just put some more kind of advanced filter regression to filter out where you want to schedule that port. Here you can see it is saying this one. Let me do one thing. I have two nodes running now. On node 2 also there is no disk, right? Let's create this. Sorry, I need to create this one. Parent. Now if I run, so I have this directory exist on node 2. I don't have this directory exist on node 1. Here you can see it is node 1, right? And in the PVC, what I'm specifically putting an affinity rule where I'm saying you need to bind this on K8 node 1, which is our this one, K8 node 1. If you run here, you can see I have this both. Let's see if it will create or it will gonna fail. 35 number. It has created, but we need to see get PV. It is saying available. But when we do a PVC, whether it will gonna create or not, if I just describe it, it is saying local volume, a persistent volume backed by local storage on a node, and this is the path it has created. And where it has created, that's what it is not. But due to this node affinity, it must be on this K8 node 1. but as of now it is not showing me. So what I will do is I will create a PVC from this file now. If I'll show you this file, it is the same file, persistent volume claim, that's just the name, and I am requesting from a storage class name called this one. And it is required a PV already created, and that's what we have already done. Kubectl create hyphen f, and if I just 36, okay, it says it has created. Let's see the status. Here you can see, guys, this is pending because this PVC is required a storage class. Though we are using it with no provisioner, so we have manually created a PV and which is saying it is available, but it is not creating. It is saying the pending. Let's see what is happening inside that PVC. Kubectl describe PVC, and I just describe. So it is saying waiting for the first consumer to be created before binding. Again, it is the policy which we have put here is maybe I need to check the storage class with no provisioner 34. Okay. So here you can say it is saying wait for the first consumer. Anyways, now let's try to schedule our pod using this. So here what I am saying is till here we are familiar, and here I am just using the storage class which was there. Now if I just create kubectl create f, and one more thing, if you see in this file I am using a node selector, so I am putting a this node must be created on K8 node 1, where we have instructed our PV to be created on node 1 with the node affinity rule. Okay, so let's create this file and let's see what will happen to our pod. Okay, let me delete this because this MySQL is not required as of now because it is failing with some additional parameter like root password or something. But I just want to be interested in my this one. If I just want to kubectl describe pod and I just give the name of this pod, so here it is saying initializing failed for volume this path MNT disk vol1 does not exist. Can you see, guys? That's what I just wanted to show you because here we don't have any disk, and since we are using a no provisioner, so obviously there is nothing, there is no one that who can create and spin up that disk, right? That is the difference between the provisioner and the no provisioner, because there we haven't created this path. It was automatically created this PVC, and when we deleted this PVC was gone away. But since here we are using this, so let me see if I just create manually. And one more thing, before I create, let's check the PV and PVC status. Although it is saying bounded, because it has bounded, but it is not finding that is why it is failed. Now I have created, and if I show the I'm not sure whether it will gonna pick automatically or not. Okay, maybe we just need to delete kubectl delete pod, and the pod name is this one. Let's delete this. It has deleted. Now if I just run PV and PVC, so it is still bounded, right? And we have chosen the retain. Let me delete this again. Kubectl delete PVC, deleted. Kubectl delete PV, and here I would say this one. No, this is not PV. PV is this one. It's deleted now. We are left only with storage class. Okay. Now let's quickly create a kubectl create hyphen f, and I need to run 35 first, and then I need to run 36. And if I just list PV and PVC, so it is still saying pending because it is waiting for the first consumer. Okay. Now let's create our port with the option 1, which is 37. Kubectl get port. This time you can see it is up and running. And if I go my this directory, it is not yet started. Okay, it is running. PV and PVC is bounded. It is keep on running. Okay, sorry, we are in wrong directory. We should be in this one. And you have this test log where we have our entry coming in the live. Let's see 8, 9, 46, 51. Now the entries are coming, right? It will be 56 for now. So that is the way, like you have this. There is one thing, if I cat this 37. So in 37, what I'm saying is it should be defined on where? It should be defined on where we have this node 1 because I am using a node selector. Whereas if I am just cat the 38 number file, so 38 I am saying you need to do the same thing, but here I'm using again a node affinity. So this node affinity I'm using in the storage class as well, and I'm using for the pod as well, because there you need to define, right, where you want to do it. Let's say if I just change this to K8 node 2, and let's quickly create. So what do you think? It will get scheduled or not? For me, not. Why? Let's see. It's still pending. Describe pod, and this is the node affinity pod. And again, it is saying that local PVC not found. Why? Because if you see this definition of this pod file, it is referring to a local storage, which is just a logs. It is a local PVC. But if you see kubectl get PVC, you don't have anything which is called local PVC, right? That is the uh, issue, because we don't have that PVC. If that PVC is there, obviously it will get scheduled. I hope this was clear, like how the dynamic storage works in the Kubernetes, and we have seen already a static where we just manually created. So dynamic is nothing, only you just need to find out that the provisioner thing, right? Where you can go and you can find all. Let's see if we can find the documentation for provisioner storage class. I'll just want to show you what all it has supported. It is a local storage provisioner, it is saying. Let's see. Okay, it is just the, no, I want all stuff. So if I go to a parameter winding mode, yeah, see, this is the, if I'll go to, let's say, Azure disk, okay. So for Azure disk, you are defining a provisioner called this one Azure file, which you just need to specify first. The Kubernetes Pro suggests that you use the Azure disk third-party storage driver instead. So if you go to this path, so these are the CSC driver, like we have done for our, which one? We have done for our local rancher. one-time solution. So this is just a one-time you need to create so that your CSI driver will create, which can talk to your external storage and do that stuff. So again, these are the additional parameter which I was talking about, like under which storage account you want to create, what is the location if you want to specify. SKU name is nothing like a kind of the performance, you can say what kind of performance you will get, like standard LRS, like local replication storage, or zonal replication storage. So all these stuff you can define with the, and these parameter are specific to that provisioner. It is not something that will be kind of applicable to all, no, right? So that for that you just need to check all these documents. So here you can see that there are multiple which is deprecated. So that thing also you need to keep in mind whenever you are doing all this stuff, that you need to see. AWS EBS, right? So EBS, you can see that this is the CSI driver, you need to run it. You can just read that, okay, how to use all these. For static provisioner you need to use, for dynamic you need to use this, for mount option you can. So you need to go through all these documentation, right? I cannot, you can see that driver installation, how you can do that AWS CLI driver installation, all these stuff you need to. So based on your use case, again, it is highly recommended go with the documentation and check whether that is supported. If supported, what are all CSI drivers are available, and you need to create that, and then basically basis on that you can create your storage class, you can create your PVC, and whatever the policy you have defined, basis on that your PV and PVC get provisioned. Okay, so that was the dynamic storage in Kubernetes. I hope it it was good enough to make this topic to clear understanding. If yes, then please subscribe and like my content, and I will meet you in the next video where we will see that what next topic we can pick, maybe the security or maybe the networking will start. All right. So thank you guys. Thank you being with me. I will meet you in the next video.